Oregon's Icelandic-like volcano. During the last several years, millions of people around the world have watched the frequent and episodic effusive eruptions occur on Iceland's Reykjanes Peninsula. But, what if I were to tell you that such an eruption could not only occur within a section of the United States, but actually did occur around 11,000 years ago? What I am referring to is the Devil's Garden volcanic field, which in 9000 BCE produced a 3.2-year-long eruption that resulted in 38 square miles being covered in a layer of lava which averaged 40 feet thick. And, despite the fact that the vents which fed this eruption will not erupt again, the volcanic field it is a part of is still considered as active. In other words, this little-known volcanic complex may one day erupt again, despite today containing no surface activity such as gas vents or hot springs. Devil's Garden. So, why exactly did the Devil's Garden volcano, which measures 6.1 miles wide and 10.8 miles long, form? The short answer is the disappearance of regional glaciers after the last glacial maximum 21,000 years ago combined with the disappearance of a 1,000 square mile Pleistocene lake 15,000 years ago. Both of these features had placed large amounts of strain on the underlying crust, causing it to sink downwards. But, once this mass was removed, the crust rebounded upwards, creating numerous faults and weak points for magma to intrude into. As a result, between 20,000 and 9,000, but most notably 12,000 to 9,000 years ago, areas of the world which at one point had glacial cover saw an increase in the rate of volcanic eruptions by as high as 300%. Yet, the volcanism which formed these features indicates that they are not part of the Cascade mountain range, hence their different composition. Instead, they are part of a strange province known as the high lava plains, where during the last 15,000 years repeated large outpourings of lava have occurred from multiple complexes, leading to a cluster of black lava fields so large that they are each visible from orbit. The eruptions in this province were triggered by a quirk on a specific section of a subducting tectonic plate. Although the exact reason why this occurred is unclear, in geologically recent times a high lava plain's small portion of the Havander-Fuca plate was unexpectedly pulled downwards at a steeper angle. As a result, viscous material in the mantle was quickly forced into the empty space the recently shallower angled plate once held, creating a curved motion that pulled molten rock upwards. Fairly sizable volumes of the molten rock pulled upwards by this action subsequently intruded into the crust, some of which eventually erupted, forming the volcanoes of the high lava plains. The Devil's Garden lava field formed around 9000 BCE when a 2 km or 1.24 mile long dike of magma began rising through the crust. A plume of white volcanic gases then started rising from 3 points on the ground until suddenly a fountain of lava